Okay, guys, what was your question?
Problems
64 or yeah,
67.
46, 47.
Problem 40, 40, ha ha ha. 67? All right.
I think it's a typo, but I could be wrong.
No, I got that right.
Is that supposed to be a squared or no?
Supposed to be a squared or no?
So at the top of your, what is that called?
Oh, yeah, that's supposed to be x squared.
Yes.
Yeah, that should be x squared. Yeah, I meant to put a square there. I mean, you could still solve the problem without it being squared, right? I mean, but yeah, you're right. So I've got 2. So I'll put the corrected one here, x minus 1, x squared minus 6x divided by x squared minus 2x x minus 3 Yep. So, yeah, that was what I intended there. So I will give you the first step, and I'll leave you the rest. But so what I would do is notice that that's x minus 3 squared, and that's x minus 1 squared times x minus 3 times x minus 4 times x plus 4. So from that, I can tell you that, as we think about graphing it, no one of consequence. Let's see here. We have like x equals 1, 3, and 4. Those are interesting points to think about, right? What would the horizontal asymptote be for this function? What happens as x gets really, really large? This is a cubic. This is a 2, 3, 4, fifth order, right? So when x gets really large in the positive or negative sense, this whole thing tends to 0, and we're just left with 2. So the graph should have like a horizontal asymptote of 2. So there's that. But anyway, so the other question you guys had was what, 59? $59, was it?
Yes.
Any other typos?
Yes, on 59. Okay. Is that supposed to be a 9 instead of 8?
No, I think that's an 8. So we have, let's see here, we have r of x equal to, can you guys, just a second here. Number 59, yeah. So r of x is, what is it? It's 2x, man, I cannot read. 2x to, uh-huh. Uh-huh. And what are we supposed to do? We're supposed to use the rational roots theorem, or rational zeros, aka rational zeros theorem, and list the what? List all the possible rational zeros for r of x. So this problem is actually like way, way easier than the first one you guys asked me about. Because all you have to do is list the possible rational zeros. I don't even ask you to, I don't even ask you to check which ones are actually the zeros, if any of them are. So all you have to do is remember what the theorems say. It says Rational roots are where something like factor of over factor of, and how did it go? Which one was on top, which one was on the bottom? Factors of the leading coefficient, factors of the constant coefficient. Which one was on top? The constant. Factors of the constant coefficient. And factors of the leading coefficient. So here, leading coefficient is that, right? And over here, you've got the constant coefficient. And so what are the factors? 1 and 2, right? This one has factors 1, 2, 4, and 8. And of course, plus or minus, right? Well, what are the possibilities? Like 1 over 1, 1 over 2, 2 over 1, 2 over 2, right? And so forth. So you got like, what, 4 over 1, 4 over 2, 8 over 1, 8 over 2, and then plus or minus all those. Some of those are redundant, right? Like 2 over, like in this case, this and this are the same thing, you know? So the list is actually shorter than the 16, I'm imagining. 16 because it's 8 and then plus or minus, you know? But it's actually not that many. But yeah. So we just have to list them, that's all. Does that make sense? Like the next step, if the problem was harder, was, and this problem would be much more annoying if I just added the sentence and determined which of them are actually zeros. Yeah, you just exactly just plug those numbers into X for the formula and see which one actually work, if any.
So when you get repeated ones, you don't have to write it twice, right?
Right, yeah, I mean, I would, so of what I've already written, I would have like plus or minus 1, plus or minus a half, you know, plus or minus 2, and then this one I don't even, just doesn't matter, right? Like 4 over 1, 4 over 2, 8 over 1, 8 over 2. So you notice also this one and this one are the same, right? So, oh, and this are the same. Good grief. Maybe I've already given you all the answers. Sorry about that. Plus or minus 2, plus or minus 4, plus or minus 8. I think that's it. I'm sorry, I seem to have solved this problem. My apologies.
I have another question about number 60 when you say it just factored over.
Oh, let me. What number was this? In case people, let me write down. Problem 59. Because I'm going to send a link to this to the other section, because they did not have any questions yesterday, and unfortunately for them, the homework is due tomorrow. Yeah.
There's not going to be another Rickroll, is it?
What's a Rickroll?
You don't remember?
I'll send you a link. Let's see here. Which question?
It was just, when you say factor over the reals, like say I got a,
So what does factor over the reals mean?
well, I know that, but can I leave,
Uh-huh.
one of my factors to be a quadratic?
Can I leave factor of quadratic? Yes. So, for example, if I had f of x equal to x to the 4th minus 1, that would be like x squared plus 1 times x squared minus 1. and then that. So this would be factored completely over the reals. But it's not factored completely over the complexes, right? Over the complexes, you can take a step more, and you can break that down. Like over the complexes, it's always possible to take, at least in principle, to take an nth order polynomial and write it as a product of n linear factors, possibly repeated, you know. Other questions? You guys must have other questions. Problem what? Oh, this was just a question.
The page with 47, 48, 49, like how to look at the graphs and interpret the equation.
So your question is like how to get started on 48 and 49? Sure. Yeah, I can't decide. Let me kill some of the lights. Let's see here. So I give you a graph, right? And you're asked to find p of x, which could have a graph which has the same shape, and x-intercepts is the one given below, right? So I've deliberately removed the scaling from the y-axis. Like I don't give you any information about the y-axis. That's on purpose. So it's all just about the shape and where it crosses the x-axis, right? So let's just take it bit by bit, right? Like problem 48. What could you tell me from this graph? I mean, it has a crossing at -6. Yeah, bounce at -2, crossing at 4. That's really all the information that we can get from that graph, since we don't have any sense of scale on the y. So, you know, the cross at x equals -6 suggests that there's a x plus 6 factor, right? The bounce at x equals -2 suggests a x plus 2 squared factor. Or, of course, it could be x plus 2 to the 4th, right? Could be x plus 2 to the 6th. It has to be even, though, because it bounces, right? And likewise, for the first one, it could have been an x plus 6 to the cube, right? It could have been a cube. It could have been a 5th power, right? I think I said, well, I think some of the problems I wrote, I said find the polynomial of least degree, right? So if I want the polynomial of least degree that has this kind of shape, then I definitely want to opt for the x plus 6 rather than x plus 6 cubed, right? Because x plus 6 gets the job done. I don't need x plus 6 cubed. I don't need x plus 2 to the 4th power because this will suffice to give me the bounce. And what was the other thing here? 4, right? So the crossing at x equals to 4 suggests a x minus 4 factor. So what does that mean? That means we can put these together to form the formula for the polynomial, right? So p of x, how about x plus 6, x plus 2 squared, and then x minus 4. That's a contender, right? What's the thing I should worry about, though? Part of shape is that the bounce is below the axis, right? And then it's crossing from above to below and then from below to above on the other side, right? So we should check that the general sign of this makes sense, right? So what could you check for this formula? If this formula is going to be a legit answer, I seem to be like I'm solving problem 48 for you. I'm sorry. I'll actually invent a similar but different problem next problem you asked me about. Sorry about that. So for this one, I need to check that it actually has the right shape, right? So to think about that, I could think about, well, if I plug in 6, it should be positive, right? If I check that, then we should be okay because we know that the formula can only cross from positive to negative where it has zeros, and it only has zeros where we've given them, namely 4, -2, and -6. So if I plug in 6 to this formula, what happens? Like P of 6 is what? Positive, positive, 6 minus 4, positive, plus, plus, plus is plus. I think we're good, right? Another way to look at it, this has x times x squared times x. It's like x to the 4th overall. So, P of x, my P of x is x to the 4th for x going to plus or minus infinity, right? And so that's kind of what we're looking for the big shape here, because it does that. Does that help? I mean, I guess that should definitely help for this problem. I just told you the answer, but but I hope that I've given you a roadmap to solve the other one, right? It's like this one. You look at it and you go, okay, well, you've got a bounce at -6, right? And a crossing at -2, and a bounce at 4, right? So you can follow the same game plan to try to construct the formula for P of x for that one.
So say you plug it in and it gives you the wrong sign, what can you do?
Oh, you just slap a minus on the front, turn it over. Yep, yep. So her question was if it was upside down of what you wanted, then you could just, what would you do to fix it? You'd multiply by -1. I don't know if I even have a problem like that in the homework. It's just something that occurred to me as I'm talking to you guys about it. A way that I could make the problem more confusing to, take points away from people on the test. So, good question. We'll call it Mary's question. Let's see here. How about problem 47? Find in addition, the y-intercept is 20, right? So let me work a similar but different problem. It is very much the same thing, but there's a new player, right? That y-intercept, right? So no, we cannot do that. So let's find polynomial of least degree with the following features: bounce at x equals to -8, and crossing at x equals to 1, and a bounce at x equals to 6. All right, and y-intercept of I'm thinking, I don't know, 1,000. All right. So here's how I do it. I'd say, okay, so I want is P of x. So to get that x plus 8, I get x plus 8 squared. That gets me the bounce I want at -8, right? To get the crossing I want at x equals to 1, multiply by x minus 1. And to bounce at 6, right? Now, here's something that I haven't emphasized a lot, but the point of this question, in fact, is partly this, is if you multiply the example by a number, it does not change where the x-intercepts are, right? Or even that there's a bounce, right? Like, think about this. If I multiply f of x by 3, it doesn't change where the x-intercepts are, right? It just stretches the thing out, but the x-intercepts stay put under a rescaling vertically. And so what I'm trying to say is I can put a number here, let's call it a, and it will still have all of these. I just set a equals to 1 in my previous example just because, you know, I didn't need to do anything else. I think I'm out of frame. Oopsie. There we go. Sorry about that, people at home. All right, so I was saying, you know, and then once we have that a there, we have to figure out which choice of a makes the y-intercept be 1,000, right? So what do we do? How is the y-intercept related to the formula for the function? This is always true, as long as 0 is actually in the domain. Is p of 0, right? We plug in 0, that gives us the y-intercept. But that's also equal to 1,000, right? Because I said we're looking for a y-intercept of 1,000. But then I plug in 0 up here, and I get a times 64. Well, a times, 0 plus 8 squared times 0 minus 1 times 0 minus 6 quantity squared, which is, minus 64 times 36 a equals to 1,000. So apparently a equals 1,000 over, 64 times 36. And there's a minus, whatever that is. So, I mean, I left my calculator back in my office, and I don't. Yeah, what's 64 times 36? Sure. 2,304. So I have minus 1,000 over 2,304 times x plus 8 squared times x minus 1 times x minus 6 quantity squared. So this problem I've just worked out is very, very analogous to, problem 47. This is basically problem 47 tilde. Other questions? We should look at one of the ones that involves long division or involves the complex case, right? Because I don't think we've talked about that enough. Let's see here. 55. Oh, by the way, how about this one? Problem 51. I should talk about that while we're here. I have a polynomial. It's fourth order. I told you it has zeros, minus 2, 0, 1, and 3. And then I give you that a3 equals to 4. How do you work that out?
We do the same thing we did on that was where we put 59. Put it over.
I think we, yeah, I mean, I would suggest to you that problem 51 is actually very similar to problem 47. So let me just suggest to you the problem is to figure out, I mean, I'm trying to say here, you could put an A out front, and can you guys tell me, it's A times what? If I want to get zeros of -2, 0, 1, and 3, what do I put? A times what will give me those zeros? How do I create a polynomial of fourth order that is 0 when I plug in -2, when I plug in 0, when I plug in 1, when I plug in 3? I'll start us out. You already did it for me. All right, now I got nothing to do. How about 0? What do I put there? Just x, right? X minus 0 is just x. X minus 1, all right. And then what? X minus 3, right? So on the one hand, the polynomial is that from the given information, right? On the other hand, it's also what? It's given, I tell you, it's a4x to the fourth plus a3x cubed plus a2x squared plus a1x plus a sub 0, right? And I also tell you something. I tell you, annoyingly, that this is 4. So what I'm about to tell you is that saying that a3 is equal to 4 sets the scale on the polynomial. That is going to force you to choose a particular value for that big A in our setup. Now, how do you figure out what that is? What I would do is I would multiply this out. And when I multiply this out, I will have f of x in standard form, where each one of the coefficients is given in terms of big A. And then I will be able to then compare and figure out what big A is from just focusing on the cube term.
So you multiply the A that we're doing that? Or do you like AX plus 2A?
Yeah, I'd leave the A out front just to not write it 1,000 times. But I would I first, basically what I would do is I would multiply all this first. Yeah, and I would leave the x to multiply last because it's super easy. Multiply x last. I would multiply these two first actually, then that one. But let me give you a similar but easier example. Like similarly, if I told you that f of x was equal to a2x squared plus a1x plus a0, where a1 is equal to 3, and zeros of f of x include x equals to 2 and x equals to, minus 1, then I would write f of x equals to a times x minus 2 times x plus 1. That would be equal to a2x squared plus 3x plus a0. And then I could multiply this out. And then the underlying idea here is once you have two polynomials are equal, the only way the two polynomials can be equal is if the coefficients match order by order. So like a2 has to be a, and 3 has to be equal to minus a. So I'm forced to put a, comparing this and that, this tells me that a equals to minus 3 for my made up, easier version of your problem. Really? There we go. What's that? What's my number?
What's that number?
It's some North Carolina number. It's probably.
Right there.
Whoa.
One over there.
There's so many numbers on the. There's so many numbers. Oh, this minus 3.
Okay.
So what I'm saying is, this you multiply this out, right? And when we do that, there's going to be a coefficient of x cubed, right? It's going to be like some multiple of a. That has to be equal to 4. Just like here, if I have zeros of 2 and minus 1, and I actually multiply this out, which I can do quickly because it's just quadratic, I end up with a coefficient of minus a on the x term. If I'm given that the coefficient of the x term is 3, then minus a must be 3, so a equals minus 3. Here. Sorry, you guys were trying to get me to work a different one here. Which one was it you were trying to get me to go to?
Oh, never mind, I'll change, I got it.
Oh, you got it? Okay. Let's look at problem 56, or let me try to make a problem like 56. Because I don't think I've talked a lot about that in here. Maybe not enough. Maybe not at all.
Yeah, we shouldn't even ask for it.
Ha! so, so you can kill me. For p of x, a polynomial with real coefficients if p of alpha plus I beta equals to 0, then p of alpha minus I beta is equal to 0. So this is the statement. People will say that complex zeros come in complex conjugate pairs. Like if anytime you have a complex zero for a polynomial, you always have another one. They come together. They come in pairs. And moreover, in this case, x minus alpha squared plus beta squared factors p of x. So that's the story. If we have a complex zero, that means we have a corresponding irreducible quadratic factor of x minus alpha squared plus beta squared. And you can reverse engineer this. If you have an irreducible factor of x minus alpha squared plus beta squared, that means that alpha plus or minus I beta are zeros for your polynomial. It goes both ways. Listen, problem 51 is a trick problem. I'm just trying to help you with it. Problem 51 is pretty tough. I think for the level of your course, it's actually very difficult. So I'm not expecting that you just like looked at problem 51 and, oh, I know how to do this. No. That was a challenge problem. On this one, let's see here. So I have complex zeros of 2 plus 3i and 7 minus 3i and a y-intercept of 10, right? So let's see here, 2 minus 3i. That tells me that x minus 2 squared plus 9 factors my polynomial. What did I call it, p of f? Or did I give it a name? I didn't give it a name. What do you guys want to call it? Oh, I guess I'm making a similar problem. So if I had this as my complex 0, it gave me that as a factor. If I had 7 plus I as a 0, that would give me this factor. Tell you what, I'll make it a minus 7. There we go. So if I want a polynomial, a real polynomial with real coefficients, which has both this and that as complex zeros, then I can set f of x equals to a times x minus 2 squared plus 9 times x plus 7 squared plus 1. This fourth order polynomial will have those two as complex zeros.
That's it.
Well, yeah, except in this homework problem, I also gave us this annoying y-intercept of 10, right? So if I want y-intercept of 10, what do I do then? Yeah, f of 0 is a times plug in 0, we get what? 4 plus 9, 13. 49 plus 1, 50. You know? So that's equal to 10, yeah. A is equal to 1 over 65, I guess. So like for my made-up problem, kind of like problem, I cannot read, 56, I would use, and again, problem 56 is a little bit different, right? And did I say put it in standard form? That would sure be annoying if I'd said that. Did I say that? Ah, what's that mean? That means I got to multiply it out. Ah, what a jerk. X squared minus 4x plus 13. X squared plus 14x plus 50. All times 1/65. Still not in standard form, right? Standard form means we write it 1/65 x to the 4th plus 10 x to the 3rd power.
No, you would have 2 points on this one.
63. Hey. Fine. Note to self, put on test. Here. And you know, you had. Hey. Is that
Well, if it's worth 2 points again.
6? I think that's 6. Anyway, you guys could multiply these out. It's not a big deal, but. And of course, you could also, like, you know, use Wolfram Alpha to multiply them out if it doesn't give you joy. I wouldn't be bothered.
I hope so.
It's trying to use the reverse psychology.
No. You gotta go.
Look, now here, problem 57 is very much the same theoretical corner of this universe, but it's asked in the opposite way. I give you the polynomial of order 4. I tell you that minus 2 plus I is a 0. How do you approach this problem? How do you solve problem 54? So notice that f of minus 2 plus I equals to 0 tells me that x minus 2, rather x plus 2 squared plus 1 factors f of x. So of course this is really just what? X squared plus 4x plus 5, right? So what I'll do is I'll divide x squared plus 4x plus 5 into the given quartic. Plus 10, right? Well, right, if I want to factor this out of that, I think long division is the easy way to do it. So you guys get me started. What do I write? It's 110. Oh, I should stop. Should I stop? What's 110? I should. Oh. Yeah, it's interesting how the dynamic of the class turns when I'm doing your homework for you. Your x squared. So we get 3x cubed plus 4x squared. So plus 3x, yeah? So that gives us minus 8x squared plus 8x. Oh, that feels wrong. Plus 10. I feel like I made a mistake.
What is that? It's supposed to be 11. The x.
7,
Oh, never mind. Subtraction.
7 minus 4 is 3. Let's see here. 3 times 4 is 12.
Okay, it's squared wrong. So then 19 minus 5.
19 minus 5 is what? Is it 4? 14, right. 14 minus 12? 2. Aha. So then that is exactly twice. Well, minus 2 that, right? Well, this should be, oh no, not minus 2, it's just still 2. 14 minus 12 is 2. And so, plus 2. So we have just learned that this quartic factors as x squared plus 4x plus 5 times x squared plus 3x plus 2. But this, of course, we can factor further, right? The other one is irreducible. Problem's not completely done, but I've given you a very significant hint, I think. So, anyway, I'll stop here.
Might want to check the video and cut some stuff out.
Cut some stuff out.